All right, guys, today we're looking at factoring. If you are in second block, you're going to be looking at parts 1 and 2. And fourth block, you're only looking at part 1 today. Part 2 will be tomorrow in class. So first things first, by definition, a factoring is when we express a polynomial as a product of other polynomials. Now, we're going to look at several different formats for this. But I also want to call attention to the fact that the order in which I am giving you these factoring methods is very important. And it is the order in which we will attempt to factor all of our problems from here on out. So the first factoring method is GCF. GCF stands for greatest common factor. Once again, greatest common factor. So what that means is we want the largest number or term that will divide evenly into all of the terms listed within our polynomial. Again, we'll model this in just a second when we get to our examples. As I mentioned before, the order that I'm giving you these factoring methods is very important. So GCF is always the first factoring method that we will attempt. I did write out some steps for factoring by GCF. It's kind of hard to put into words. In fact, I think this makes it almost sound a little harder than it is. But I still know that some of you like a little something more concrete. So I tried to write it out. Number one is, of course, that we need to identify that greatest common factor. So we've got to figure out what it is. Once we do that, we're going to divide the existing polynomial by the GCF. And so that quotient that we get, the answer after we divide, is the second factor. So to write our answer, it's literally the GCF times the quotient that we got after we divided. Once again, I'll show you that once we get to our next example. By the way, feel free to pause along this video if you guys need more time to write something down. Just communicate it to Ms. Hutchinson, and I'm sure she'll be happy to kind of delay the video for just a second. So first things first, with our example, this did kind of write a little strange when I tried to copy it. This is 6c to the third d minus 12c squared d squared plus 3cd. So to identify our GCF, again, we want the largest number that will divide evenly into each of the terms. So 6, 12, and 3 are all divisible by 3. Then I need to look at my variables. If the first term has c to the third, remember that's c times c times c. So there are literally 3 c's in this particular term. This one has 2 c's, but this one just has 1. So I can't take 3 or even 2 away from a term that only has 1. 1 c is what's part of my GCF. D is going to be the same way. Again, this term has 1, this one has 2, this one has 1. So the most I can take away from all of the terms is D. 3CD is my GCF. The second factor in my answer is what I get when I divide the original polynomial by my GCF. So 6 divided by 3 is 2. There were 3 c's. We took 1 away, which leaves us with 2 c's, so c squared. There was 1 d. We took it, so it's gone. Negative 12 divided by 3 is negative 4. There were 2 c's. We took 1, which leaves 1. There were 2 d's. We took 1, which leaves 1. But be careful here at the end. I have a lot of students that want to stop right there. That's not true. 3 divided by 3 is 1, not 0. We took the only C, we took the only D. This is our answer. And guys, if you are ever unsure about your answer and you want to be able to check, you can absolutely just redistribute that GCF through and see if you get the original problem. If you don't, then you've done something wrong. But if you do, you've done it correctly. All right, so in class, if you'll pause the video for just a couple of minutes, work through these examples. I want to give you time to look at them and see if you can get the right answer. Again, just pause the video really quick. When you're ready to resume, hit play, and I'm going to work them out as well. 6, 3, and 12 are all divisible by 3. I can also take at least one x away from each of these terms. 6 divided by 3 gives me 2. 3x's, I took 1 away, leaves me with x squared. 3 divided by 3 is 1, which I'm not going to write. X squared divided by x is x. Negative 12 divided by 3 is negative 4, and we took the only x. On this one, 5, 10, and 35 are all divisible by 5. And I can't include any x's in my GCF because the last term doesn't have any. So 5 is the GCF. When we divide by it, 5x squared divided by 5 is just x squared. Negative 10x divided by 5 is negative 2x. And 35 divided by 5 is 7. On the last one, a little bit larger, 16, 8, and 12. The largest number that will divide evenly into all of those is 4. By the way, if you find yourself struggling, you can always come over on the side and kind of make yourself a little list of the factors of each of the numbers. So like 16, for example, of course, I could do 1 times 16, I could do 2 times 8, or I could do 4 times 4. I don't know why I shouldn't have done it that way. Let me show you a different way. Like a prime factorization. Here, I'll write it over here. So like 16, for example, you could do any of those that I just gave you. So 2 and 8, 4 and 4. If we break it down as much as we can, kind of like you would if you were simplifying square roots, 16 ends up being 2 times 2 times 2 times 2. And I can do the same thing with all of these numbers. So like 8 is 4 times 2, which is 2 times 2 times 2. 12, I can do 2 and 6. It doesn't matter if you start with 3 and 4, you still end up with the same answers. So here's the prime factorization of each of these numbers. To figure out my GCF, it's what they have in common. So each one of them has a 2, another 2, and that's all they have in common. Because now, see, this only has 1, 2, but this only has 1, 3. There's nothing else that they have the same. So my GCF is 2 times 2, which is 4. Now, the variables are a little bit easier because, again, you can count with your exponents. If this one's got 3, this one's got 2, but this one only has 1, I can only take 1 away. Same thing with my y's. There were 4, 2, and 3. 2 is the smallest. And then this one only has 1 z. So 4x y squared z is my GCF. Now I just need to divide by it. 16 divided by 4 is 4. There are 2 x's left, 2 y's. Here, negative 8 divided by 4 is negative 2. There's 1 x left, no y's, and 2 z's. And then 12 divided by 4 is 3. No x's, 1 y, and 1 z. There's my final answer. All right, let's keep going. Second factoring method that we want to talk about is the difference of squares. And difference of squares will always be in one particular format. Difference, guys, remember in math means to subtract. And when we're talking about squares, we're not talking about the shape. We're talking about numbers that are something times themselves. Again, something raised to the second power. So I mean numbers like 1, because that's 1 times 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. We could keep going if we wanted. These are the squares that I'm talking about. That's what we're looking for. So difference of squares, if we kind of put it in a little general format here, again, it's going to be something squared minus something else squared. Could be something like x squared minus 25, for example, because x squared is obviously x squared. 25 is 5 squared. What's the difference of 2 squares? When we factor a difference of squares, we take the square root of the first thing. Excuse me. So like x squared is x times x. Sorry. And then we take the square root of the second thing. So 5 times 5, or 5 squared, is 25. Then if you follow the format here, one parenthesis has a plus sign, one parenthesis has a minus sign. And guys, the reason that this works out is because if we were to refoil these together, the inside term and the outside term would reduce out, leaving me with only x times x and 5 times negative 5, which is x squared minus 25. So if I look at this example, I know that it's a difference of squares because I see the minus sign, first of all. And then I know that x squared is x times x. And I know that 16 is 4 times 4. As with all difference of squares, one is a positive and one is a negative. Now, the fraction kind of scares some of you at first, but this is also a difference of squares. Now, most of you probably went straight to the 81. That is 9 times 9. And with all difference of squares, one's positive, one's negative. You even see your x squared with the x times x. But don't be confused on the 149th either. Guys, 1 is 1 times 1, and 49 is 7 times 7. So same thing, you can pause the video for just a second to practice these on your own, and then click resume when you've had enough time and you're ready to check. Difference of squares, because x squared is x times x. 121 is 11 times 11. One's positive and one is negative. On this one, we might have a GCF also. I wonder if 169 is divisible by 3. If it's not divisible by 3, it won't be divisible by 9, by the way. 3 divides into that, 15 times, that's 19, so it doesn't work. Okay, so it's just a difference of squares. I just wanted to check. So 9y squared is 3y times 3y. 169 squared is 13 times 13, so we've got to include that x there as well. 169x squared would be 13x times 13x. Again, one is positive and one is negative. Now, in terms of number 3, of course, I've put the warning to be careful. When you factor it as a difference of squares, x to the 4th is x squared times x squared, just like 16 is 4 times 4. But when you put your 1 plus and your 1 minus, what I want you to recognize, class, is that we actually have a second difference of squares right here going on. So we don't have a rule about a sum of squares. So the plus side just comes down. But I can refactor x squared minus 4, again, as another difference of squares. X squared is x times x. 4 is 2 times 2. 1 is positive and 1 is negative. Our third and final factoring method for this first part of the lesson is the trinomial method. And remember, the prefix tri means 3. So we're identifying when to use trinomial method, excuse me, based on the fact that we have 3 factors within our, or 3 terms, excuse me, within our polynomial. And I kind of usually do a little cheat sheet with these. It's not really a cheat sheet. Some little sign tricks to watch out for. I don't know. I'll try to explain it as I go. So when we're factoring by trinomial method, it's essentially FOIL in reverse. Meaning that I want to look at what times what would give me my first term, what times what would give me my last term, and then manipulate the signs so that my inside and outside terms reduce to whatever it is that they need to. I'll show you what I mean. But I did try to write out some steps for this one as well. So you can pause, fill in as you need if you're trying to take notes over any of this, or of course you're welcome to just hang on and kind of follow through the examples. I'm going to turn a little slowly. Feel free again to pause if you need to. It actually just occurred to me that I should probably just copy this and make you a note sheet, and then we won't have to pause because you'll have the steps. So I'm going to keep rolling. I did include an example in here, but honestly, I'm going to just jump to the one for me to work out. So this is that little signs cheat sheet that I was talking about. Some students like this, some students don't. I personally don't really use it very much, but I know that it has helped some of my students in the past. And I don't really know what's going on with the typos there. So if I'm looking at my trinomial, the second sign kind of tells me whether I'm going to be adding or subtracting my middle terms. And then the first sign is just what the sign of that answer is going to be. And so, again, I can show you this a little better than I can explain it. But so if I've got a plus plus, I'm going to add to get my middle terms, and both signs will be positive. Whereas if I have negative positive, we're going to add to get the middle term, and both signs will be negative. So anytime we add, both parentheses will have whatever the first sign is. But if we're going to subtract to get that middle term, the first sign tells me, oh, I see what happened now. That's supposed to go there. That's supposed to go there. Again, when I subtract, the sign in the parentheses will be whatever the sign of the bigger number is. Not the sign in the parentheses. Oh my gosh. Just hang on and watch. All right, this is an 18. So first of all, this problem totally has a GCF. 6, 12, and 18 are all divisible by 6. And when I factor out that GCF, I am left with x squared minus 2x minus 3. From here, I can factor again using trinomial method. The 6 for my GCF does just come down. Here's how trinomial method goes. I'll look at my first term. X squared is x times x. Then I'll look at my last term, and its factors will go in the last spot. The only factors of 3, by the way, are 3 and 1, or 1 and 3. You can put them wherever you want. But we need to manipulate the signs so that my inside term, 1 times x is 1x, and my outside term, x times 3 is 3x, will subtract and give me a negative 2. Well, the only way that I can subtract them is if signs are different. So one's positive, one's negative. Okay. And for my answer to be negative, the bigger number has to be negative. So I need a positive 1 and a negative 3. This is my answer. Once again, the last sign tells me if I'm adding or subtracting my inside and outside terms. And you don't have to show this work. I'm just trying to give notes and show you kind of what I'm doing. Next example does not have a GCF. 13 and 5 are both prime. So we're going straight to trinomial method. And if I'm being 100% honest with you, this one is a pretty tough problem because 6x squared could either be 6x times x or 2x times 3x. And so we've got to kind of play with both of those options. So 6x and x or 2x and 3x. Now the factors of 5 have to be 5 and 1, so that's kind of nice. But what I don't know is, do they go like this? Or do they go like this? Same thing here. It could be the 1 and the 5, or it could be the 5 and the 1. So these are all different options. You don't have to draw them all out. Again, I'm just trying to explain. I know that I'm going to be subtracting my inside and outside terms, and I want to get a positive 13 as an answer. So I'm not going to draw them out this time. I just want to talk through them. My inside term here would be 1, 1x. My outside term would be 30x. 30 and 1 will never subtract to give me 13. That doesn't work. Here, 5 and 6 cannot subtract and give me 13. That one's out. 3 and 10 could add and give me 13, but not subtract. So that one's out too. But 15x and 2x will absolutely subtract to give me 13. For my 13 to be positive, my 15 needs to be positive and my 2 needs to be negative. Once again, I'm talking about the inside term, 15x, and the outside term, negative 2x. 15x minus 2x gives me 13x. Okay, so this is my answer. All right, so once again, hit pause on the video, try to work these out on your own, and then click play when you're ready to resume and check your answers. Factors of x squared are x and x. Factors of 6 are either 1 and 6 or 2 and 3, but I need them to subtract and give me 5, which means it's going to be the 1 and the 6. To get a negative 5, the 6 needs to be negative and the 1 needs to be positive. On this one, factors of 3x squared are 3x and x. Factors of 20 could either be 1 and 20, 2 and 10, or 4 and 5. By the way, when I'm coming up with my list of factors, I start with 1, and I just go in order, 1, 2, 3, 4, and since 5 is next, but 5 is already listed, I know that I'm finished, and I have listed all of my factors. So factors of 20, I need them to subtract and give me 11, but not just these. I have to include the 3 in terms of my inner and outer terms. So I want numbers here and here that will subtract and give me 11. The 1 and 20 is pretty out, because if I were to put my 20 here and my 1 here, I've got 1 and 60, definitely not working. Even if I switch them, 20 and 3 are not going to subtract and give me 11. If I use my 2 and my 10, 2 and 10, that's 2 and 30, still not working. If I switch them, and I'm just doing this so mentally we can talk about it, 10 and 6 will not subtract and give me 11, so that's out. Got to be the 4 and the 5. We just got to figure out where they go. If I put the 4 here and the 5 here, that's 15 and 4. 15 minus 4 is absolutely 11. Because it's kind of guess and check on some of these ones with multiple factors. Number 3 has a GCF of 3x. Once I factor that out, I'm left with x squared minus 2x minus 8. GCF comes down, and we can factor again by trinomial method. X squared is x times x. Factors of 8 are either 1 and 8 or 2 and 4. But to subtract and get 2, it's going to have to be 2 and 4. Positive 2, negative 4 will give me that negative 2 that I want. So this is my final answer. And then on the last one here, 18, 24, and 10 are all definitely, definitely divisible by 2. Pausing for just a second to think if there's anything bigger than that, but I don't think so. So if I factor out a 2, I'm left with 9x squared plus 12x minus 5. And then from here, I can factor once again by trinomial method. However, 9x squared could either be 9x times x or 3x times 3x. So we've got some choices. Factors of 5 have to be 5 and 1 or 1 and 5, wherever you want to put them. But guys, to subtract and get 12, I'm thinking it's probably going to be the 3x and 3x, because 9 is just huge, first of all. I'm either going to get 45 and 5 and 1, or I just lost my train of thought, or 5 and 9. Neither one are going to subtract to give me 24. So with my 3x and 3x, I've got 15x and 3x. 15 and 3. I just confused myself, didn't I? Factors. Oh, I'm not adding to get 24. I'm sorry. I'm subtracting to get 12. That's what I meant. So 15 minus 3 gives me 12. Sorry, I kind of screwed up on that explanation there. All right, so if you are in 4th block, you're going to stop the video right here. Your assignment today is actually, I feel like it was slightly different than that. You are, let me just double check. Yeah, you're doing page 19, 2 through 36, every other even. So that's if you're in 4th block. If you are in 2nd block, you're going to keep rolling because we've got another lesson. Again, 4th block, you'll resume the rest of this video tomorrow. So factoring part 2. Yay, more math. I know, you're so excited. Really quick, so far we've talked about GCF, difference of two squares, and trinomial method. These will continue to be the 3 main factoring methods and the order in which we will complete them for the rest of the course. So now, I start to say today like I'm doing it on a separate day, but anyway, now we're going to focus on solving by factoring. Essentially, it's the same setup, except we have to account for the equal sign, obviously. What we want to do is get everything in what we call standard form. Standard form has all of the components of our polynomial on one side of the equation set equal to 0. So for a regular quadratic function, which is what most of which we're factoring, that's going to be ax squared plus bx plus c. Notice that my x squared is first in order, by the way, followed by the x term, and then the constant term. It is also important that this leading coefficient be positive. So if it's negative, the way that your problem is written, you would move everything to the other side of the equation. Since this x squared coefficient is positive, we want to bring everything to it. So we're going to start by subtracting the 3x. All that does is move it to the other side so that we can essentially rewrite our problem as x squared minus 3x equals 0. Now it's in standard form. Now, these two terms have a GCF. That's always what I look for first, which is x. When I take an x away from each of these terms, I'm left with x minus 3. This cannot be factored by GCF again. It is a difference, but those are not squares, and it doesn't have enough terms to be a trinomial, which means we're finished factoring. Here's where the new stuff comes in. Once my polynomial is factored, I want to set each factor equal to 0, and we're going to solve those independently of one another. Now, guys, the reason that I'm setting it equal to 0 is because of what this equation says. Something times something else is 0. Folks, the only kind of multiplication problem that you can do and get 0 as an answer is if one of the factors themselves is 0. Like 0 times 5 is 0. 12 times 0 is 0. Again, any number times 0 is 0. So to get 0 as an answer, one of these two things has to be 0, which is what we're doing. We're setting them equal. First one is already solved. This one we add 3 to both sides, so x is 3, meaning that 0 and 3 are our solutions. And I'm going to write those as a solution set. Let's keep going. On the next term, once again, we're not quite set equal to 0 yet, so I want to add 4 to both sides. Just moving it over, so I've got m squared plus 4m plus 4 equals 0. And there is no GCF here, but, and oh, sorry, and it's also not a difference of squares. I see no minus sign, and there are more than 2 numbers. This is a trinomial, 1, 2, 3 terms. So this is FOIL in reverse. Factors of m squared are m times m. Factors of 4 are either 1 and 4 or 2 and 2, but they need to add and give us 4, which means it's 2 and 2. Since we're adding, both have the same sign. Now, technically, we set both factors equal to 0, but guys, when the factors are the same thing, don't waste your time. If you put m plus 2 equals 0 here and then m plus 2 equals 0 here, you're going to get the exact same answer. Subtracting by 2, m is negative 2. You can write that as a solution set. Sorry, I got a little ahead of myself as well. Keep it on rolling. So next thing, I want to subtract 6x to move it over, leaving me with 2x cubed plus 4x squared minus 6x equals 0. I have a GCF here of 2x. When I factor out that GCF of 2x, that's x squared plus 2x minus 3. But what's left in parentheses, I can factor again by trinomial method. Factors of x squared are x times x. Factors of 3 are 3 and 1, but to subtract and get a positive 2, it's got to be positive 3 minus 1. Now that it's factored, I set each factor equal to 0, and I solve. So dividing by 2, x is 0, subtracting the 3, x is negative 3, and adding the 1, x is 1. Pretty massive solution set here, all 3 digits. Now, as I said, so far we've got these 3 factoring methods that we can use to either factor or solve. But it's possible that as we're working, some polynomials just won't factor. Like you can't do one of these 3 methods. So when that happens, our fail-safe, like something that works all the time, is quadratic formula. Now, before somebody is thinking, well, why didn't you just teach us quadratic formula, Miss Esters? Because I know it's probably Trace, too. Trace, don't make fun of me when I'm not there to defend myself. Anyway, So the reason that we don't do quadratic formula all the time is because it's long and it's hard and it's got a lot of little steps. And some of the answers look a little janky, for lack of a better way to say it, all right? So let me show you what this would look like. I've already told you that. Quadratic formula is, and if you had a good Algebra 2 teacher, I hope they made you sing a song or at least played one over and over again so that you just know this thing. If you don't have it memorized, that's okay. We're going to be using it enough that you're going to get really used to it in here as well. So quadratic formula is x equals negative b. Goodness, I'm sorry, it's so late. I keep yawning. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's typically how we hear it read. Now, to use quadratic formula, we have to be able to get our functions, our equations, excuse me, into standard form. The a is the coefficient of the x squared, b is the coefficient of the x term, the linear term, and c is the constant. And those a, b, and c variables are what we're substituting into quadratic formula in order to get our answer. So let's look at our first problem. This is not in standard form. So much like our solving problems earlier, we want to start by moving that 33 over to the other side. Now, this one actually does factor. 33 could be 3 times 11, which will subtract to give me 8, just saying. But I want to use one that's easily factorable to also show you quadratic formula, because we can get some nice answers with quadratic formula and we can get some really funky answers with quadratic formula. So let's look at a nice one first. So once it's in standard form, I want to identify my a, b, and c values. Remember, a is the coefficient of the quadratic term, the x squared term. So there's an understood 1 here. B is the coefficient of the linear term, or in front of the x. And c is the number that's by itself, the constant. Notice, guys, that I do not keep the x squared or the x with those terms. It is just the coefficient, just the number, okay? So quadratic formula, because we don't know it yet, really, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what I want to do is substitute these values into the formula. So if the formula is negative b, but b is negative 8, what is negative negative 8? Be careful with your signs here is the point. Change the sign. Now I'm under the radical. Notice that because that b is negative, I'm going to make sure I put it in parentheses as well. Remember that negative 8 squared and 8 squared negated are two very different answers, okay? So b squared minus 4 times my a value of 1 times my c value of negative 33 all over 2 times my a value. Now, if you were to type this into a calculator, first of all, you can't because it's got a plus or minus sign in it, and you're not going to find that on your calculator. You could technically divide this into two problems. You could do 8 plus all that crap over 2, and you could do 8 minus all that crap over 2. And in this problem, if I'm being honest with you, you're going to get an answer that's pretty nice. But in the vast majority of the problems that we're going to work, you would get a decimal, and we don't want any decimal answers, like ever, on quadratic formula. We're either going to have nice, pretty numbers, or we're going to have fractions, or we're going to have radicals, or we might even have some imaginary numbers later on. So here's what I want you to do when you are simplifying these quadratic formula problems. First of all, I should always, 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 like 100% of the time, see this substitution step. Because if you miss your answer, that's the first thing I'm going to look at, is to make sure that you have your numbers in the right place and that the signs are right as well. So after the substitution step, what I want you to do is bring down anything that is not underneath the radical. So the 8, the plus or minus, the square root itself. You can even go ahead and multiply whatever is in the denominator. So like 2 times 1 is 2. From here, we're going to use our handy dandy little calculator, which I'm using my little ghetto one that I keep under my phone. And we're going to type just what's underneath the radical in the calculator, not the radical itself. So for example, and I'm going to try to get this in view, I'm doing negative 8 squared minus 4 times 1 times negative 33. Again, there is no radical, but it matches what's underneath it, okay? So that is 196. Now, the reason that I want you to do that step separate is because of, again, the other types of answers that we're going to get. But for right now, you can also, and you can try to take the square root, that's fine. But if it gives you a decimal, you have to do it by hand. So the square root of 196 is a nice number. That's 14. And if you don't know that you can still do it in the calculator. All right, square root of 196, see, 14. So from here, I simplify again. That's 8 plus or minus 14 over 2. But the plus or minus part is the headache, but only when the radical goes away. It's kind of weird. The nice answers are actually the worst ones, and the ugly answers are kind of the easiest ones. You don't have as much to do. All right, so from here, we actually split this into 2 separate problems because we have to address the plus or minus sign. We want to do 8 plus 14 divided by 2, and we want to do 8 minus 14 divided by 2. 8 plus 14 is 22, divided by 2 gives me 11. 8 minus 14 is negative 6. Negative 6 divided by 2 is negative 3. So my solution set is 11, negative 3. Let's look at another one, though, just to be a little more consistent. So this one is already in standard form, which is really nice. I'm ready to identify my variables. A is 1, B is negative 34, and C is 289. So substituting into quadratic formula, that is negative B, B's already negative, so it becomes positive, plus or minus the square root of B squared minus 4AC all over 2A. And I don't want you to think that A is always 1. It's in these examples that I've given you so far, but it can be a lot of different numbers. So just kind of be careful there. Step 2 is to bring down everything that's not under the radical and then type what is under the radical in our calculator. So let me try to keep this in view again. I'm doing negative 34 squared minus 4. I'm not going to do my times 1 because it just makes it the same thing. All right, so we get 0 here underneath the radical. Now, if you don't know what the square root of 0 is, you can type it into the calculator as well, but the square root of 0 is 0. So here's my question. 34 plus 0 and 34 minus 0 are what? As 30, anything plus 0 is that number, anything minus 0 is that number. So essentially the 0 just kind of goes away again because 34 plus 0 is 34, 34 minus 0 is 34, which leaves me with just 34 over 2, which is 17. Now remember, it is possible to only have one answer. We had one earlier in our factoring lesson where we ended up with, like, I don't remember what it was, x plus 2 times x plus 2. So we got the same answer maybe. I don't remember if that was the sign, but something like that. All right, let's do another one. Also already in standard form, A is 1, B is negative 6, and C is 2. By the way, this is an example of one that would not factor. The only factors of 2 are 2 and 1, and that won't add to give me 6. Okay, so this is one that has to be done using quadratic formula. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Bringing down everything except what's under my radical, and then I'm going to type that into my calculator. So negative 6 squared minus 4 times 1, I don't know why I did that, times 2 is 28. Now, for those of you that just love the calculator, here's where the problem comes in. If I had put the radical with it and I try to take the square root of 28, I get a decimal. We don't want decimal answers. We want exact answers. So that's why I'm having you write this little step right here. Because when it's not a perfect square, like zeros and 196 that we've already had, we have to break it down by hand. So you're kind of getting a little mini lesson within this lesson. The square root of 28, the way that we simplify any square root is to do a prime factorization. We want to break it down. So 28 is what times what? Well, I could do 7 and 4, for example. 7 is prime, but 4 is 2 times 2. So radicals, when we get ready to simplify them, honestly, when I teach simplifying radicals, I usually make some kind of stupid joke about it's a little bit like dating, okay? In order to leave the house on a Friday night, you need a date. So you and your significant other together are a couple, singular. There's only one couple. You get to leave the house. Anyone that doesn't have a date is lonely and is going to stay at home, okay? Now, obviously, I'm being silly here. So when the couple comes out, there are a couple of twos living out of the house. 7 is home alone. Okay. So if the square root of 28 is 2 radical 7, I'm making that substitution over here. Everything else just came down. And we are almost done. Sometimes we'll be finished at this step. But when all 3 of your coefficients, your whole numbers, will reduce by the same number, like 6, 2, and 2 are all divisible by 2, we can reduce the fraction. I want to be very clear that it has to be all 3 numbers. It can't be 1, it can't be 2, it's got to be all 3. So 6 divided by 2 is 3, 2 divided by 2 is 1, which just leaves me with square root of 7. And again, 2 divided by 2 is 1. You can put it over 1 if you want, but that's a little unnecessary. 3 plus or minus the square root of 7 is our answer. I've got one other example to show you, and that's this one right here, which first of all is not in standard form. So we want to move our 6x over, being careful to put things into decreasing order. So x squared, then the minus 6x, then the 13. Once it's in standard form, I can identify my A, B, and C. And I'm sorry, guys, my lights keep going out because nobody's moving. So A is 1, B is -6, and C is 13. I can substitute that into quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over to a. Everything comes down except for what's under my radical. And this time, oops, I just hit the wrong button. This time I get 88. No, I don't. I typed that wrong. Sorry. Should be a minus sign. There we go. -16. Now, the negative under the radical might throw you for a second. So let's talk for just a minute. First of all, what's the square root of 16? We all know that. We should all know that. Square root of 16 is 4. But here's the deal. The square root of 16, or the square root of -16, excuse me, is the square root of 16 times the square root of -1. Square root of 16 is 4, but the square root of 1, as we will review later, but you should have seen before in Algebra 2, is the imaginary unit, I. So the square root of -16 is 4i. Now, just to keep it simple for this lesson, because we're not really going to be doing a whole lot of identities with our imaginary terms, all that you need to remember right now, guys, so that we're not freaking out, okay? All that you need to know is that you simplify the number like normal. Break it down, any pairs we bring out. The negative comes out as an I. That's literally all you need to know. Because after you bring it all out, we simplify it just like we did the previous problem, in that you're either finished, or if all 3 numbers are divisible by something, you can divide. 3 plus or minus 2i is my final answer. Now, I know that this is a lot. I expect us to have a little bit of difficulty with this. Remember that I've built in that Monday entire class period for us to review, refresh, test corrections, bonus, like whatever we need to do, we're going to take care of. But as far as today's assignment goes, remember that you are keeping, let's see here, what's the assignment for this one? This one is 38 through 54 even. So 38 through 54 even. So for those of you in fourth block, this is your only assignment for today. Those of you in second block, you are combining both of the page 19 assignments. You should work on those a little bit today. You should work on them some on your own. So a little bit of homework. You don't have to finish the assignment maybe on Thursday, so that when you come back to class on Friday, you can just finish up whatever you didn't get done. You will still all be responsible for that quiz on Friday, though fourth block, you'll get a little bit of online practice as well. I hope you guys are doing okay. And just remember that if you get stuck or you have specific questions, you are welcome to reach out via email or remind. And I'm happy to help you any way I can. See you guys soon.